The voltage transfer characteristic of a Cmos inverter describes the relationship between the input voltage, V_in, and the output voltage, V_out, of the inverter. A Cmos inverter consists of a P-type metal oxide semiconductor, PMOS, transistor and an N-type metal oxide semiconductor, NMOS, transistor connected in series between the power supply voltage, V_DD, and ground, GND. The input voltage is applied to the gate terminals of both transistors, while the output voltage is taken from the output terminal that connects the drain terminals of both transistors. When the input voltage is low, i.e., below the threshold voltage of the NMOS transistor, the NMOS transistor is in the cutoff region, and the PMOS transistor is in the saturation region. In this region, the output voltage is high, i.e., equal to V_DD, because the PMOS transistor acts as a closed switch, connecting the output to V_DD. When the input voltage is high, i.e., above the threshold voltage of the NMOS transistor, the NMOS transistor is in the saturation region, and the PMOS transistor is in the cutoff region. In this region, the output voltage is low, i.e., equal to GND, because the NMOS transistor acts as a closed switch, connecting the output to GND. The voltage transfer characteristic of a Cmos inverter is therefore a plot of V_out versus V_in. It is typically represented by a graph with two regions, a high region and a low region. The high region corresponds to the input voltage range where the output voltage is high, and the low region corresponds to the input voltage range where the output voltage is low. The transition between the high and low regions occurs at a voltage known as the threshold voltage, V_th, of the NMOS transistor. The threshold voltage represents the input voltage at which the NMOS transistor just begins to turn on, and the output voltage begins to transition from high to low. The voltage transfer characteristic of a Cmos inverter is typically very sharp, with a steep transition between the high and low regions. This makes Cmos inverters useful for digital logic applications, where precise switching behavior is required.